Welcome to this recitation session for lesson 3. The first question asks, given the following setup, we have the points A and B, and there's a point C that is at the intersection of the horizontal and vertical lines drawn in orange as shown. So we want to find out what are the coordinates of this point, and we also want to know what the values of delta x and delta y are, and additionally we want to find this distance between A and B. So how do we go about doing that? Well, observe that this horizontal line drawn through A is the line y equals 1, and the vertical line drawn through B is the line x equal 1. So we can easily just read off the point C as 1, 1. For part B, we want to know about the increments as you're traveling from A to B. If you're traveling along this horizontal line and then along that line, what is the distance along the x-axis and what is the distance along the y-axis that you've traveled? Of course, we know how to do this. You just calculate delta x and delta y using the coordinates of A and B, and we get delta x is 2 and delta y is 1. We can just directly use these values, delta x and delta y, to calculate the straight line distance between A and B. So as in this formula, we just plugged in delta x and delta y to get the square root of 2 squared plus 1 squared, which gave us square root of 5 units. We always write units if we're not given any units by default, whether it's meters or whatever. Question 2 says, write an equation for the circle of radius 5 units whose center is at the point -3, 4, and sketch the circle to show its relation to the coordinate axes. So we already know from lesson 3 what the equation of a circle is. We just need to plug in the radius and the point that represents the center in the equation of the circle. So we've gone ahead and done that. We state the equation of the circle and plugged in these respective values a, b, and r to get this equation. 25 equals x plus 3 squared plus y minus 4 squared. And to sketch this circle on coordinate axes is really straightforward. We just draw the axes, plot the center at the point -3, 4, and make sure that we draw the circle in such a way that the line that represents the circle is always 5 units away from the center. And this is what it will look like in relation to coordinate axes being plotted. Question 3, let L be the line that passes through the origin and makes a 45-degree angle with the positive x-axis, and find the coordinates of the points on that line that are exactly 1 unit away from the origin. So this one's a little tricky because you have the line L drawn at 45 degrees in relation to the positive x-axis, and they want 2 points that are exactly a distance of 1 away from the origin. So how do you find the coordinates of those points? Well, we already know how to find distance using the formula from before, and we know about increments. So how can we use increments to do this? Well, observe that if you're finding the distance between, let's say, the origin and B, or even the origin and A, we must have delta x squared plus delta y squared square rooted equals 1, because the distance must be exactly 1 away from the origin. But this line is the line y equals x, so delta x and delta y will be the same, and using that in this formula we can easily figure out what delta x is. So delta x from the origin is going to be 1 over root 2, because as you can see, since y is equal to x, we can have delta x twice under the square root sign, and that gives us 2 delta x squared square rooted, and that goes in both directions because for B it'll be y is equal to x, both coordinates being positive, and for A it will be y equals to x, both being negative. So it's a simple matter to see that the coordinates for A and B would be these coordinates and these coordinates respectively. Question 4, a particle starts at 6, 0 and the coordinates change by increments 2 and -5, delta x and delta y respectively. Where does it end up? Well, we just use the formulas again for finding delta x and delta y, but we switch it around because we want the destination coordinates, which is x2 and y2. And it's a simple matter to just use x1 from A and delta x and x2 from A and delta y in order to get the coordinates 8, -5. Question 5, particle moves along the parabola y equals x squared from the point A11 to the point Bxy, where x is not equal to 1. Sketch the parabola and show that delta delta y over delta x is equal to x plus 1 if delta x is not equal to 0. This one is a little bit different, but you'll see that it's a matter of algebra in order to get the thing that we want. So delta x is easily x minus 1 and delta y is y minus 1 because b is xy, a is 1, 1. And when we're calculating, we get delta y over delta x equals y minus 1 over x minus 1. But remember that y is equal to x squared, so that's why we're able to plug that into here. And the expression x squared minus 1 is the same thing as x squared minus 1 squared. And we know from algebra that the difference of two squares is factored as, in this case, x plus 1, x minus 1. Or if you remember the rule, a squared minus b squared is equal to a minus b into a plus b. And then we can cancel with the denominator to get x minus 1. Of course, we don't want delta x to be 0 because as you can see, we're dividing by x minus 1 and that's delta x. So if that's 0, that's a problem because we don't divide by 0. So this is the end of this recitation. Please remember to subscribe and I look forward to seeing you in future lectures.